Good morning, Algebra 2. This is Mr. Morales. I'll be discussing the solutions for our absolute value 6 weeks test, version A. Pardon me while I take a drink. I've been making videos all morning. Alright, so here we go. Graph the function and give the domain and range for each. So we're given the function f of x equals the absolute value of x. This is our basic absolute value graph, which you could actually use to help you with numbers 6, 7, and 8 coming up. So the domain would be all real numbers. We have our basic graph here. It goes infinitely left, infinitely right, as it does for all three of these. So we have a domain of all real numbers for the first three examples here. Our range for our first graph is everything from 0 going on up. Remember, range is measured on the y-axis. The y-axis is basically our ruler. This graph does not go any lower than 0 on the y-axis, but it does make contact. So the graph exists everywhere that is greater than and equal to the number 0 on the y-axis because it goes infinitely up. For question 2, f of x equals the negative absolute value of x plus 2 minus 4. Domain, once again, is all real numbers. When you graph this, the plus 2 tells us that we're going to move left 2 units from the origin, and then the minus 4 means we're going to go 4 units down to have our vertex of this graph. Once we graph our first vertex point, we look in front of the absolute value bars for our slope, and we have a minus 1. The 1 is not there, but it's understood that there is a 1 in front. So that means down 1 over 1, and that's what I did to make my graph. Once I graphed it, I went ahead and found the range. The range is going to be measured on the y value, or the y-axis again. It does make contact right here with the value of negative 4, but it goes down, so it'll be everything less than that amount infinitely. For part 3, or question 3, I don't know why I keep saying part. For question number 3, we have f of x equals 1/2 the absolute value of x minus 1 minus 3. Domain, once again, will be going infinitely left and right, so we have all real numbers. To graph this graph initially, start at the origin again. The minus 1 tells us we're going to the right 1 this time, and the minus 3 outside means to go down 3 units. Here's my vertex. My slope is going to be 1/2. That means rise up 1 square over 2, which means we're going to have a wider, widened graph here. And you do the same thing in both directions because these graphs are symmetric or even. Once I finished graphing this, I went ahead and found my range. My range is everything that is greater than the value of negative 3. And it does exist or have a solid vertex at negative 3. It's continuous there. So it's everything y greater than or equal to negative 3. For questions 4 and 5, they want us to write the equations based on the graph. So the first thing you need in order to write an equation is to figure out your slope. How much is your graph rising and running? So your vertex at any point on a line or on an axis makes it a lot easier to read, especially these graphs that don't have grids everywhere. So I started at the vertex, lined everything up with my ID, and I said, okay, if I'm going up 2 squares and then over 2 squares to get to my next point on the graph, up 2 over 2, that's my slope, which is basically a 1. So I have no real difference in slope for absolute value. So I can just start with an absolute value symbol, absolute value bar. The 1 will be basically here but invisible, and I don't necessarily write it. I do know that my vertex is 4 units to the left, which looks like a minus 4, but when we write it in absolute value form, it's going to be plus 4 in the brackets. It has then dropped 2, which is going to be minus 2 outside the brackets. So there's my equation. For number 5, I once again found my vertex, found a point on the axis, and I determined my slope. I noticed here that if I go down 2 units and over 1, down 2 over 1, I get a slope of negative 2, or negative 2 over 1. So I begin my equation with negative 2. I then start the absolute value bars and throw an x. And now I just ask myself, okay, where's my vertex located? Well, it's 5 units to the right of the origin, so that's going to be a minus 5, because that's opposite thinking when you're doing the absolute value bars. And then it's risen 2 units up, so that's plus 2 outside the absolute value bars, and there's my equation. For number 6, 7, and 8, I can go ahead and just refer to number 1 if I did my graph correctly, or if I know this topic well enough, I can go ahead and just look at these equations and explain what's going to happen. Now it does say explain how the functions differ from the parent function. I wrote everything, but most students, I realized, read the instructions and just put the differences, which is great, and I appreciate that. But if you didn't, you wrote everything, that was fine too. So here's what we have. We have a positive absolute value graph that opens upwards, a slope of 1, because there's no other number here in front. It's going to be 7 units shifted to the right and moved 5 units up based on this plus 5. For number 7, compared to the original graph, because of the negative sign, it's reflected, or it's upside down, opens downward from the x-axis. We have a slope of -1, because we have no other number in front of the absolute value bars, so a 1 is assumed to be there. And there's no left or right shifting, but there is a vertical shift of plus 10 units up. For number 8 over here, we have f of x equals 2x. A positive 2 means it's opening upwards. A slope of 2 means it's going to be narrow because you're going up 2 over 1, up 2 over 1. So you're going more up than you are over. It goes to the origin, so it's not shifting left or right or up or down because there's nothing being either added, subtracted inside or added, subtracted outside of the absolute value bars. On to number 9. For number 9, it says, oops, let me get that in view, that might help a little bit. Start with the f of x equals absolute value of x equation, shifted up 3 units, and then shifted left 4 units. So I wrote down what those translations mean as far as the equation. Shifting up 3 units is going to be outside of the absolute value bars, and shifting 4 units left would be represented as plus 4 inside the bars. We have nothing mentioned about the slope or direction, so we don't add anything in front of the bars or change anything. Same question again for number 10, but now we want it to reflect over the x-axis, which means we need to have some kind of negative value in front of the absolute value bars, and it's going to be shifted 4 units up. So we have a negative absolute value of x, no left or right changes, so nothing happens inside the bars, and then shifted 4 units up means we have plus 4 outside of the bars. For numbers 11, 12, and 13, we're asked to solve for x. So all this really is basically solving two-step equations. You make sure your absolute value bars, there's nothing outside happening, no multiplication or adding or subtracting, anything like that. And we just have the bars as is. So you take the equation inside of it, or the expression, and you set it equal to your answer, the positive version and negative version, and just solve to get your 2 solutions. In this case, for number 11, we get -8, 4. We prefer to put our answers from least to greatest, but I would not take off if you didn't do that. For number 13, here I have 3 times the absolute value of x minus 1 equals 21. I have a 3 on the outside of my bars that's being multiplied, so I have to get rid of it by dividing both sides by 3, because I need to get the absolute value all by itself before I start solving this as equations. So I divided both sides by 3, and I get x minus 1 equals 7. It cancels out from the left, and 21 divided by 3 is 7. Now I go ahead and do like I did in the previous example, and I just solve x minus 1 equals positive 7 and x minus 1 equals negative 7, get my 2 answers, and wrote them in from least to greatest in brackets. Number 13 was to see if you actually understood what was happening here. Here we have the absolute value of 2x minus 5. There's nothing happening outside of the bars, and the answer says that it equals -7. Remember, you cannot have an absolute value problem that equals a negative number. So we have no solution for this one. So there should have been any other answer except for no solution, or maybe a lot of people did this, and that was fine too. For number 14 and 15, we were asked to graph the inequalities. So we have y is greater than or equal to, so that means I'm going to have a solid line that faces downwards with a slope of 1, so I go down 1 over 1. My vertex will be 3 units to the left and 4 units up from the origin. 3 units to the left, 4 units up. You're going to go down 1 over 1, down 1 over 1, down 1 over 1, over and over again on both sides. Solid line, and you're going to shade in everything that is greater than or above your line. So it should look something similar to this, with your shading hopefully making contact with the line, because everything, including the line, is a solution. For number 15,